Okay, so we're going to be going over 6.4. Please note that we are skipping 6.3. So now we need to go over how to do a long truth table. And I'm sure you're wondering, what is a long truth table? Why do I have to do this? Or hopefully you did the reading first and you're not asking those questions, but let's go over it anyways. The idea here is that we don't know what the simple propositions are. Okay, so going back to 6.2, they told us A, B, C are true, X, Y, Z are false. We had no idea what A, B, C meant in the English language. We didn't understand what the simple propositions were, but they told us what the truth value was, and we could tell them what the overall sentence was. Okay? Now, in the real world, very rarely do we actually know if the simple proposition is true or false. So what you do is you create a truth table with all the possibilities. So what we're going to have to do is we're going to start with arguments. So right here is an example of an argument. This one has one premise and it has one conclusion. Whatever is above the line, those will be your premises. Whatever is below the line, that is your conclusion. Okay? So now that we've got that squared away, let's move on to how do you decide how many rows are going to be in your argument. If you go to page 342 in your book, it's the first section, first page for 6.3. And you'll see there's a little equation there, L to the n power. So L here is the number of lines that you'll need in your problem. And n is the number of unique simple propositions. So in this case, we have B and we have R. So we have two simple propositions. Okay? So for this one, we have 2 to the second power. So we're going to need 4. And of course, if we had 3, that would be our new equation. And 2 to the 4th, we're definitely not going to go any higher than that. Okay? So that tells us how many lines we need. And as you can see, I've already got 4 lines ready to go. Okay? So what we're going to do is we're going to create a truth table with all the possibilities. And then once we're done, we're going to ask ourselves, is this a valid or invalid argument? So if you remember, a valid argument is given that the premises are true, the conclusion must follow. So what we're going to do is we're going to do this entire truth table, and then we're going to look at it. And this is what we're looking for. To determine validity, you go through every row of a truth table to find a row where all of the premises are true and the conclusion is false. If that exists, it's invalid. If that does not exist, then it's valid. So again, valid argument, given that the premises are true, the conclusion must follow. So if there's a case where all the premises are true and the conclusion does not follow, it's invalid. And that's why we're doing this truth table. We're doing this truth table to determine the validity of the argument. Okay, so what we're doing now is taking this argument, and we're going to create this table down here. I've created most of it for you. You're going to take the simple propositions and put them over here on the side. And this is usually a little bit darker of a line here. Then you're going to separate your premises from the conclusion. The 2 dashes means your conclusion is coming up. If we had more premises, we would do something like that. So 1 dash means premise. 2 dashes means conclusion. Okay, it's just a way of formulating it. Okay, now what we're going to do is, for this one, copy some things down. So since we only have one simple proposition as our premise, we can just copy this down. So this is what B is, so I'm going to copy it over here. Okay? And we're also going to copy down R. And I'm going to go ahead and do this one over here as well. Okay, now, next step. We need to take care of the tilde just like we did before. So if R is true with the tilde there, it becomes a false. And of course, if you're wondering where that's from, it's right there. Okay? Now, we're going to combine. We're going to look at this one right here. And we're going to look at the negation over here. And we're going to combine it with the OR. And there's your cheat sheet right there. So we have T or F, which will give us true. We have false or true, which will give us true. True or false, give us true. False or true. And now we have, ooh, that did not work out well. It was all trues. Okay, so hopefully you understood how we got this line of trues. Okay, so what we're going to do now is we're going to do this last step right here. So we're going to look at every row, and then in this case, it's a really small argument. So we're simply looking for where conclusion is false and the premise is true. And since all of our conclusions are true, we automatically know this argument is valid. Okay, let's go on to a little bit more difficult of one. Okay, same process, we just got a different argument here. And again, the 1 dash means the premise, 2 dashes means the conclusion. We only have 2 simple propositions again, so we know we're going to have 4 lines. Set it up. TF, TF, TT, FF. We'll do a longer one pretty soon. Again, you want to copy everything down to begin with. This is setting the standard here so you don't get confused. So B is TT, FF, and C is TF, TF. B here is TT, FF. And C again is T, F, T, F. Okay, so that's just copying everything down. Now we need to go back and we need to bring the B and the C together with the wedge. So we're using this as our guide. So we have true or true, which is true. True or false. True. False or true. True. False or false. False. And now we're going to go to the negation. So now we're going to look at this one. So if C is true, not C is false. True. False. True. Okay. Now, there's a reason why I changed the colors. This is the lines that we're paying attention to. The other ones, we only needed them to get to the red lines. Okay? Or actually column, sorry. So now we're looking to see, is there a row where the premises, here's our 2 premises, are both true and our conclusion is false. And if you guys will notice, this one right here, true premise, false conclusion. So that means this argument is invalid. Okay, so next one. Here's our argument over here. Still just 2 simple propositions, but as you can see, they're getting a little bit complicated now. So we're going to start taking some shortcuts as well here. So we have this guide over here. This tells us basically everything we need to know. So what we're going to do is, instead of copying down O, we're just going to do not O. So T will get to F, F will turn to true, T will turn to F, F will turn to true, and same thing with K. We're not going to copy down K, we're going to copy down not K. So we'll end up with false, false, true, true. Okay, and then we can bring those together with the main operator, and in this case the only operator, right here, the wedge. So false and false gives us false, true and false, true, false and true, true, true and true, true. And that's the one that we want to pay attention to. We just did the blue in order to get there. Okay, and now we'll do not K again, so we'll just copy it over from right there. Okay, and now we need to do K dot O. So K dot O is right over here, and now we could copy this down, or we could just look over here. So the first one is true and true, so that's going to be true. Second one is true and false, that's going to be false. False and true, false. False and false, false. And then I usually just like to put parentheses around it to remind me. So that's everything inside the parentheses. Now we need to bring this column right here together with this column, and we're going to be using the horseshoe. So now we're over here. Okay? And remember, with this one, the order does make a difference. So we have if false, then true. So if false, then true is true. If false, then false is true. If true, then false is false. And the next one is still if true, then false. Okay, that's underneath the main operator. So the main operator is the last thing you do, or the thing that connects most of it together. So this horseshoe connects the not K and the K dot O together. So that's why that's the main operator. Okay, last line is our conclusion. So we'll just copy down the O and flip the sign, so we'll have not O. So we'll have false, true, false, true. And then we'll just copy down K. And then we're going to bring it together with the last one, the biconditional, our equivalents. So we have, remember, if it's different, it's false. If it's the same, it's true. So we have false and true, different, false. True and true, same, true. False and false, same, true, different, false. Okay, now the last step is we are looking for the premises to both be true and the conclusion to be false. So we got a false one here and we got a false conclusion here. So the other lines don't matter. And if you look, this has got a false here, true, oh, but that's false, so that doesn't count. We got a false conclusion, this is false, so that's not going to work. So there is nowhere on this truth table where all the premises are true on one line and the conclusion is false. Therefore, it is valid. Okay, now we're going to do a little bit harder one. Okay, so again, here's our argument. This time we have 3. So we got 2 times 2 times 2. So that'll give us 8, which is how I got that number. Just remember, go back to page 342 if you need help with that. Okay, so let's start with our first premise here. So we have M or not H. So I think the only thing we really need to copy down is probably the not H. So we'll just take everything in the H column and flip the sign. Okay, let's go ahead and do M as well in the next one. Of course, the order that you do these doesn't really matter. I tend to like to get everything set up first. Okay, that's all we're going to need for our premises there. So let's take the M column here, the not H column over here, and we're going to bring it together with our OR. So again, with the OR, if there's a T anywhere, it's going to be true. The only time it's false is when they're both false. So I'm just looking to see where I have my T's, to be honest with you. So we have a true, true. And that one's going to be false since they're both false. Both false. True, 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 true. Okay, we're done with that one right there. Okay, now let's bring the O column right here together with the not M. Only this time we're going to be using the horseshoe. So the only one that matters is if true, then false. So if true, then false will give us false. If false, then false is true. If true, then true is true. If false, then true is true. If true, then false is false. If false, then false is true. If true, then true is true. If false, then true is true. Okay. Got our premises done. Now let's start working on our conclusion over here. Okay, so we need to start over here on this side. So we need to do everything inside the parentheses. So what we're going to do is we're going to look over here at the M column. And I just highlighted the wrong column. Sorry about that. The M column right here. And we're going to be looking at the H column right here. Again, you can copy these down the way we have been, or if you're ready to start taking shortcuts, start taking shortcuts. Okay, so we have a triple bar, which means if they're the same, they're true. If they're different, they're false. So that's all we're really paying attention to. So we got true and true. Okay. That'll be true. True and true. True. True and false. False. True and false. False. False and true. False. False and true. False. False and false. True. False and false. True. And again, I like to do the little parentheses around it. That way you don't get confused. Okay, now we need to deal with the tilde. So everything in this column, we got to flip, because that's what that little box right there tells me to do. So false, false, true, 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 false, false. Okay. Almost done. Now we're going to take the O and then this green one right here, because that's what that other side of the disjunction is. So we're going to do a disjunction. So if there's a T anywhere, we know it's true. So true, false, true, 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 and false. Okay. Now we're ready for that final and most important step. We're going to look and see if this is a valid or invalid argument. So what we're looking for is a true premise, a true premise, and a false conclusion. So we only have two false conclusions, so we're just going to look at those two. And if you'll see, it's true, true, false, true, true, false. They both make it invalid. You only need one, but we know that this argument is invalid. Okay, next time we'll go over translating and then doing a truth table.